recommender system of this world to say, let's just imagine a digital world that knows you better in terms of preferences concerned. Remember, we live in a world where there are e-commerce sites, there are search engines like YouTube, Google. So imagine if the computer knows you better in terms of preferences. I'm sure you've witnessed that. To say that you search for something, similar items of the product are recommended to you. So at the heart of modern recommender system, there is a content-based filtering that analyzes and learns from your interactions to suggest content like movies, songs, articles that resonate with your taste. So you find good my e-commerce sites vanoshandisa algorithm iwayo. They embed them into their site to say when a user visits, you may be asked to rate a product. And also they store your record in terms of your likes, so that if a user akafarira tomboti product kana kuti movie
hello sir.
Yes sir.
Can you kindly record the lecture?
All right. Yeah, it's now being recorded. So normal recommender systems, they'll be basing on data. So we are going to build a content-based recommender algorithm. Such algorithms, they are employed by the e-commerce sites of this world. Nana before and to suggest a mode by virtue of your tests. So this falls under the category of web content mining again. So let's just provide notes on the best. Okay, it's not typing. We are going to move a little bit fast. What's the recommender system? We have to do with us. So how it works? Right. Let me just copy some notes that I have prepared for you on the screen. All right. There it goes. To use the raw and also share it with you. Public chat. Which one? This one. Let me run it like this. So how content-based recommender works? One, item representation to say that we create a profile for each item. For example, it's a movie or a product, and that product, it comes with features. For a movie, the genre, the artist, the director, the cast, the main actor, and so on and so on. Then it also uses user profiling to say, basing on interaction history in terms of likes and clicks, there are some algorithms that can capture the user activity on the browser to say that when this user visited, say, cat website, he registered interest in the following areas. By those clicks, another way the content-based algorithm works, it uses similarity measurement, which is calculating the similarity between item and user profiles using metrics like cosine similarity. In our case, we are going to explore building a movie recommender system using the cosine similarity, and then it recommends or suggests items with highest similarity scores. And so that is how the content-based algorithm recommender works. So in terms of application, it is used by sites that have been listed on your screen, the Netflix, Amazon, Spotify, etc. To say vanenge vatori algorithm yekuti paunenge visit ama-sites, they gather your activity in terms of likes so that they can recommend to users who may have similar tastes. Okay, the advantages: improved accuracy in terms of, because it uses attributes, item attributes that can lead to more accuracy. To say, kana uchifarira mamovie Sylvester Stallone kuona Rambo uchada kuona imwe yakaacta, something like that. New item problem. Content-based algorithms, they recommend new items, similar attributes. It puts diversity in recommendation, and it gives a clear explanation for recommendations, because when it recommends, it will, the first preference that will come to your attention is that which has a higher similarity score is alluded here when it recommends. Okay, then scalability, it can handle large data sets, and also in terms of integration, it is very easy to integrate with an e-commerce site. So it is very scalable, to say that you can enhance functionality as the requirements come. It also addresses the cold start problem, to say that even if you are a new user who has visited the site, if you show an interest in an item, it will quickly recommend. Unlike the collaborative, we are going to explore in another lecture, the collaborative filtering technique, which bases on other user experiences. Like kuti user anenge akamboreta movie, makareta the same movie, so my chances ekuti mufarire movie yausina kuona yakareta say out of 5 are very high. So you know what is a cold start problem. It does not base on your history, and it so a new user can easily get a recommendation. Okay. The disadvantages in terms of feature extraction. Features, these are attributes that come with an entity, to say that this is our product, or this is the entity movie. It has got these features. Okay, so these are the features. These are the attributes or variables that define an entity. Then data sparsity. There's the limited user interaction. Data can affect accuracy, because Panama test user are based on the recommendation. Then overfitting, those may overfit to item attributes. So what I've done, I have shared with you a data set that we are going to interrogate. We want to build a movie recommender. That data set contains data for movies. So we are going to interrogate and recommend. At the end of it all, is a movie one as a parameter. Then it will to recommend to us movie with the higher similarity score. So we'll use the cosine similarity algorithm to recommend. So have you managed to access the data I've shared with you? Kindly check from the group, from the WhatsApp group. Can you confirm? Maona data set. The data set around the movies metadata. Movies underscore metadata. And I post them group. I'm sorry, ndazokanga paste soon after my last presentation. I pasted.
Yes, sir.
All right. So I want you to paste that, to copy and paste the data set into your root folder that you are working from. Okay. Having done so, I'm sure most of you have imported a data set before. Here I'm writing code to load data from a CSV file, and I'm just declaring a variable by the name metadata. Here I've declared my pandas library, and I've imported it and declared the pandas library, the alias name PD, so that when I want to call pandas, I'll just use the alias PD. So the code to read from a CSV file, it's not new to you. So the title of the data set, the name is movies, metadata.csv. All right. To low memory equals false. Okay, it needs a capital letter F. All right. Have you managed to import the data set? Now we want to print the data set. Say metadata dot head. Is that a hand raised?
Yes, sir. Yes, I'm not seeing the code. I'm just seeing a plain Jupyter notebook.
Class, can you confirm that you can see my code? Can you see the contents of my screen?
Yes, we can.
Yeah, I would encourage you to exit the session, rejoin. It could be attributed to poor connection. I will just try to rejoin. Should you have an alternative internet service provider, make use of it, because no one on the internet can also on our screen angle the chifamba. Right. Have you managed to import your data set? Just to refresh the mind from what we learned previously, how many records does this retain if I don't put a parameter? By default, how many records does this retain? The metadata. They had metadata.head. Plus, from your introduction to programming, and did not retain a 5. This is just to test with the load the data set. But head, display 5 first records of your data set. They got to tell, display of the last 5 records of that data set, and it, right? Then if I say head, if I say 10, it will specify, it will retain 10, the first 10 records of the data set. just to refresh the mind, and from what we learned Masuro. All right. So here we have just imported a data set. Movies.metadata. The low memory is equals to 4. It's a parameter that is used to ensure that Pandas reads the entire file into the memory at once, rather than trying to optimize memory usage by reading the file in chunks. I know we'll talk about one. And it. Right. So what we want to do, we want to compute, there is a column of interest, the vote average. We want to compute the average of the voting average. So the average social answer function on the mean here, and it. So I want to compute that metadata. Then I'm going to specify the attribute or the feature that I'm working with, which is average. Then close brackets. Then what you mean? Mean is a Pandas built-in function. Computer mean. Then I want to print the mean in the variable. The variable has been stored in the variable name random.c. Let's see how it goes. So it has computed the mean of the metadata set. You can also explore the data set, and maybe the data target explore. The describe, and describe. Do you know that my variables? All right, I want to get it describe. This is our function. All right, we describe, to go to all the variables that have numerical values. You evaluate numerical computations, and it statistical, in fact, computation in respect of the count, mean, standard deviation, 25th quarter, 75th, the max, and so forth and so on. And it. Okay. So now that we've computed the mean, we want now to calculate the minimum of votes required to be in our chart. So I'm going to introduce another variable to say we want 90%, which is the 90th quarter. So we're going to use the quantile function to do that. So let's write this code. M is equals to metadata, the data set that we are exploring. We are interrogating the vote count. To quantile. Then we specify it to 0.90. Then we want to print the variable that is stored it. All right. So this code, it calculates the number of what's required for a movie to be included, and it in our recommended algorithm. So to specify to the 90% of the vote count column. This is a column, vote count column, and it. So this means that 90% of the movies have a vote count lower than the value retained by this function. This value, 160. It means that 90% of the movies have a lower vote count, and then the value retained by the quantile is assigned to the variable m, and it. So finally, the value m tazoiprinta apa. And it. So the next thing now, we want to filter out all qualified movies into a new data frame. And it. All the qualified movies, we want to filter them out and store them in a new data frame. Okay. To do that, I'm going to introduce a new data frame that is going to hold the qualified movies. And it. Maybe we could write a bit of comments, but I'm going to share with you the Jupyter notebook with all the comments so that it can be easy for you to follow. So we want to filter out all qualified movies into a new data frame. All right. To say meta, this is our main data frame. We want to use the copy function. Then log the metadata. Sorry, metadata. The variable that we are working with is the vote count. Vote count. I can't see here. All right. Is greater than or equal to M. All right. And we close this square bracket. Then we may want to see the shape. To filter out it. All right, shape. All right, maybe perhaps before we do that, we may want to see the shape. What does the shape function does? It retains the number of columns and rows and it. That shape. So draw now the difference between those two data sets. Let me run this one. It's 45,466. These are rows. The first value retained, these are rows and these are columns. So this data set that we have imported is 45,466 records with 24 columns. Okay. So having filtered it out, I want to see the outcome or to display on the screen. So I filtered and I'm left with 4,555 and maintained the 24 columns. Okay. So a bit of explanation to the code. We are saying here that the code filters out all qualified movies into a new data frame known as Q movies. And first it creates a copy of the metadata using the copy method and it then it uses the lock method to select rows where the value in the vote count column is greater than or equal to M. Here the filter type, I'm sorry, and it then the shape function, you know, that is the dimensions in respect of the columns and rows as I've alluded, and it right. So the next step now, we want to define a new feature score, of which to do that, we have to calculate the value by applying a function to our data frame of qualified movies and it. So to do that, let me just copy the code, then I'll give explanations. Because Irakati Kurei recommend the algorithm that true builder. Let me just copy this. All right. provide. Are we moving together? Or Panwasa? All right. What is going on here? All right. Or C not defined. Python is character sensitive. Character is case sensitive, I mean to say. So when I declare C wangu ari mudiki, then panapa. Because waona ere yekuti name put out my codes is not defined. So what variable iri harisi defined. Compiler iruti parutsvaga C haisi kumuona C. Andit. Because toda kushandisa variable ratisinambo define. Python. So I'm going to correct that by changing the character casing to upper. Okay, because that is a lower case. Let me find the code. There it goes. So this code defines. We have defined a new function, but to create a function, syntax is to use this keyword runs def, and this is the function runs the weighted rating that has got those parameters, and it uses two global variables m and c, and the function calculates the weighted rating of a movie based on its vote count and average rating, voting average. It uses the IMDb formula. Actually to calculate the weighted average. I want you to explore or to read about how this formula calculates. I want you to research about the IMDb formula. I'm going to paste some notes with the explanation so that you can pursue the IMDb formula. You know it as say. Then the variable v here represent the number of votes for the movie, while R represents the rating of the movie. So my features in data frame redo, vote and vote count and vote average. And right, and the function returns the weighted average. Okay, so now we want to define a new feature, score, that we are going to add to our data frame. And our data frame on the Q movies, we want to add a new column on the feature score. Score, the variable name, we're going to name it score, and it.
Sorry, sir.
Yes.
I think banana C, I missed that part. You could see just a correct OP.
All right. Error. All right. It would name not all right. Error
Name C is not defined.
All right. All right. Now to end the parcel. Maybe in the interest of others, kuti tingova neka appreciation kekudebug. Ndiani angachitaura? Sorry? Who is the
Enoch.
user? Enoch. I want
Yes.
you to share your screen.
Okay.
Let me find the user Enoch so that we can debug together. Kindly share your screen.
Okay. Rogonega. Okay.
Right, class, let's assist him in debugging. Apo correct one. Was rubuda apa nezviri museo raanatoneseo correct one.
Richirongodaro.
Ayo isa kesa museo ripamusoro seo rawo. Ranaton.
Yeah, still the same.
All right. I want you to scroll up. I just want to check something. If you have correctly defined your variable, you don't want to see. Just scroll up. Yeah. Scroll up. Don't see your room soro. Yeah. Scroll up. Scroll up. So what you are doing here, we are trying. We are referencing C. Somewhere along the way, you did not type in this code. Let me share it with you on the public chat.
Okay.
Where we were calculating the average, the vote average using the min function. Let me just paste this code so that we can be in the same boat. Okay, let me do this. There is the code. I want you to copy and create a cell directly above the cell that is giving you an error. And the cell runs Q, runs shape, yeah, just paste it, then run.
Okay.
Right. Now that you have the C variable, I'm sure. All right. Then I think that's an issue of alignment. In the banner return, Tony. Let me see. Let me check. Yeah, retain. Yeah, you're good to go. You're now in business.
Okay.
We are now moving together.
Thank you.
So allow me to share my screen. Right. So now we are saying we want to define a new feature or variable by the name score. We want to introduce it to the data frame and calculate its value using the weighted rating. Okay, so this is the new variable or feature that we are introducing, and to do that, to go to Q movies, square brackets, the feature name, and it. So now we are calling our data frame Q movies. Say apply weighted rating, and it takes two parameters. One of the x is equals to 1. We want to run this. So what we have done on that code, we have created a new feature called score for our data frame Miromon's Q movies, and the value of this new feature is calculated by the weighted rating function, which is applied to each row of the data frame using the apply and method with the axis parameter equals to 1. The weighted rating function likely takes into account various factors such as the popularity and rating of a movie to calculate a score that represents its overall quality. And So the resulting score feature can be used to rank and compare movies in the data frame. All right. So finally, we want to sort our data frame in descending order, and it on the score feature that we've created. All right. So to do that, malaita sorting malaita programming, and it Q movies is equals to Q movies. We want to override the data set, and it, but this time around in sorted values. That's the function that we use for sorting. In the feature or the column that you want to sort, don't want the square that are created, and it. I think by default, also it will sort in ascending order, and it. It will sort in ascending order. But if you specify another parameter to specify the ascending at false, better descending order, it right. But it false, then we want to print, say, the top 15 or 10 movies. Let's just provide a comment. Here we are sorting movies based on calculated score. Yataita pamusoro above, and it. Then here we want to display, say, the top 15 movies according to score, and it. So I know sort of in descending order to say that Ombe score when get pamusoro zichitererana. So I'm going to select a few features. Remember, the data set redunema variables avawanda and columns avawanda. So I'm just going to select a few columns from the data set that I'm interested with. I'm going to pick the title. Comma. Also, I'm interested in the vote count. Comma. I'm also interested in the vote average. Comma. I'm also interested in the score, the new variable that we've created. And I'm going to close this. And by virtue that 10, print at 10, I want to display the top 10. So Notion is a head function, and it was that also that read. Saka aripamusoro ane score mbendo anenge ari pamusoro. There it goes. So as you can see from the data that is returned on your screen, we are saying it has displayed 10 movies basing on the score, the highest being on top. Okay, right? So all right. the next step that we are going to do now, come through.
Say I'm getting an error message.
Where
Like-
irutichi area one.
Irukuti pakanzi define a new feature app. Irukuti V is not defined.
V is not defined. Apa.
Iyo yanga ichiramba but yazoita after your correction.
Okay.
Then tapa iri pazasi yacho iyo.
All right. It's Tatenda, right?
Yes, sir.
Are you at liberty to share your screen with others? My program, that's debug code. Yes, Tatenda. Was the code kana isinga itema errors? There's no way we can learn. So it's part of learning those errors. If we are able to correct those errors, then we are good to go. We are good to go. So my errors handled you and got the kindly share your screen. Can you scroll up? All right.
Let me remove this.
Two more functions here.
Padova the error.
Only two more functions are weighted rating. Was one. One and two. When Mama say, all right, run part to define a function, you know, the weighted rating.
Panapa.
Run. Run the other. So, undo baba ni error yako.
Panapa ndo pani error pana.
All right. Let's run it. Let's see. All right. Scroll down. Let's see. Those are still. B is not defined. Don't sort on or something. My program. What did debug
V wake capital letter pamusoro pa R. It's a small V.
Aba.
You have to be consistent in the character casing, and it should be consistent. But
There we go.
She's now in business. So this is how you debug. You relax. What variable rukurambira right? What could be going is not defined. So what are risk oneka? Compiler redu no respect. Kutoesa capital letter here kana kutoesa small letter. So it's as easy as that. All right. Then upon also it. So let me just paste this code. To go on the same page. Right. So we are saying now. We have a problem that we are facing, which is the natural language processing problem. Hence, we need to extract some kind of features from the above text data before you can compute similarity or dissimilarity between them. So to put it in simple, we are saying it's not possible to compute the similarity between any two overviews in their raw forms. So to do this, we need to compute word vectors for each overview. Okay. It's not a variable by the name overview. Maybe we may want to first interrogate it say kuti metadata muona variable redu inonzi overview nenyaya yenatural language processing yatiri kutaura nezvayo. Overview to head. All right. So Anzo, we need to create anonymous word vectors and it which are vectorized presentation of words in a document. So the vectors carry a semantic meaning with it. For example, man and king will have vector representations close to each other, while man and woman would have a presentation far from each other, and you get the essence. Kuti kana taita anonzi vectorized representation of words, inoisa ma words ane semantic meaning closer to each other, and to say that, for example, man and king will have vector representations close to each other, while man and a woman will have a representation far from each other. To say that man and a boy will be closer to each other, I think you get the essence. So we compute what is called the term frequency inverse document frequency, TF-IDF, vectors for each document. This will give you a matrix where each column represents a word in the overview vocabulary. All the words that appear in at least one document, with each column represents a movie as before. And so in its essence, that term frequency inverse document frequency, TF-IDF, score is the frequency of a word occurring in a document, downweighted by number of documents which it occurs. This is done. So in a nutshell, we need to introduce a class, which is it's a built-in class, and it denotes the TF-IDF vectorized class that will produce the TF-ID matrix in a couple of lines. And also to batsira pakuita ma recommendations to say tika provide a movie basing on the words that have been vectorized inenge yakucomputer inokwanisa kuti recommend a movie closer to the one that we've provided. So at the end of it all, we are going to define an algorithm. We're going to build a recommend algorithm that will take a parameter and it will recommend using that. So we are going to use the scikit-learn library to build a TF-IDF vectorizer. So first things first, we want to import. I know some compilers or your Python, where and I see that to install. So we want to import the TF-IDF vectorizer. That's it from scikit-learn. All right. To do that, is to write this code from sklearn. From sklearn feature extraction dot text. And it imports TF-ID vectorizer. And it right now the second course of action, which is the comments to track with a pass up, define a TF-IDF vectorizer object. Right. And remove all English stop words. All right. So I'm going to introduce a new variable as TF-IDF is equals to. We want to call the function TF-ID. Now it starts with the capital letter T. TF-ID vectorizer. It's a class. The function. Let's see. Then here I'm introducing a parameter and stop words and it. So we want to remove all the stop words in English. All right. Right. Then we want to call our main data frame, the metadata is equals to metadata dot drop NA. What does drop NA do? Class from
What columns ningasina chin.
Yeah, it drops all now value columns and it overview. Overview. No drop a basic personal data. Not columns, ma rows, rather than ma rows. And it then we want to replace. This is for the overview column. Shall drop all now values are more overview column. Now we want to replace few movies, few any right. Overview panapantona ndine era kandinako iratoni andavaita setup. All right, let me disregard this line. I will refer back to it. And ndikazoita problem pambera. I'm just reflecting on the code that I was testing. So I'm going to leave that line of code. The next course of action, we are going to construct the required TF-IDF matrix by, let me just paste from my notes. Just paste. Where am I? I'm right here. But there's something that I want to comment that I feel is not relevant. All right, let me leave it like that. All right. So here we are saying this code is used to create a TF-ID matrix for a data set to move data. First, to import up so that and it. So we've imported the TDF vectorizer class from the Skyline library. So this class is used to convert a collection of raw documents into a matrix of TF-IDF features, and this class that I created. So next, we a TDF IDF object. This is the variable. The object has been defined to define a introduce this variable with the parameter stop words set to English. This means that common English stop words such as the will be removed, and it stop words the one another the nana and it. All right. Now a total example of stop words. The nana a and it will be removed from the text data during vectorization, and it then the metadata frame is loaded and any missing values are replaced with empty string, but at the drop in the apple. All right. Then the resulting matrix is stored in the variable is a true TDF IDF matrix, and it then finally we are printing the shape. We want to see the shape of our data frame, that is our matrix, that is in respect of its dimensions, rows and columns. That's a matrix that we've created. And so the next step now, we want to do array mapping from feature integer indices to the feature name. To do that, let's provide a bit of a comment. Array mapping from feature. Let me paste this code on the public chat so that we can move together. Okay. All right. Integer indices to feature name. To do that, we are going to call the TDF ID object that we have created, which has got a function that is called get feature names out. All right. That will Torah slice between 5,000 and 5,010. Right. We just run this code. All right. So the TDF, the TIF-DF object is likely a TF ID vectorizer object from the Skyline features extraction text module, which is used to convert a collection of raw documents into a matrix of TIFD. So the function it not get feature names out or returns an array of feature names in the order they appear in the feature matrix. So in this code snippet, slice data introducer is used to get the feature names for the indices between 50,000 and 5,000 and 5,010. syntax dzedu dzinotaura kuti the stop value, this is slicing, and this is the start value, stop value, meaning to say 10 is exclusive, and it I slice element 50 10 nengere exclusive, so I know gumera 50 09. So the output of this code will be an array of feature names for the specified range of indices, and it right. So since we have used the TF-IDF vectorizer, calculating the dot between each vector will then directly give us the cosine similarity score. Therefore, we have to use the linear KL instead of cosine similarity, since it's faster-handed. So what we want to do now, we want to import the linear kernel, then we compute the cosine and it. That, let me just paste this in the public chat before we proceed. Let's provide comments, import linear kernel. And let's say from sklen dot matrix dot pairwise import linear kernel. Now I want to compute the cosine similarity matrix. All right. I want to introduce a new variable. I want to cosine sim. It's a new variable that I have declared. I need to hold the output or the result linear kernel. It receives the following two parameters: TF-ID matrix, and again it takes the same value, the TF-ID matrix, not over two more parameters. And it, you want to run this. This one, it takes quite some time. And the young way right. I want to share you and the public chat. Mute tab. My tab was muted. All right. Right, we have an error here. We have an error. Unable to allocate 14 for the data type. And yeah, error. Memory error. And error. Can you try to run it? Let me try to fire it again. All right, let me do this. Kernel. And run more cells. And I want to see how it goes. We'll start up to pizza redo. Maybe it could be a memory machine. Right. Yeah. 1 second. Do something. Speaking of patients, when I need you home and you want to relax on it. And I go at 3 and a memory shoma. Hope it to execute. Let's just give it time. It's you know what I'll freeze.
Chico freezes some
Test.
You are now
Who freeze some machine? Is it on? Let's just give it a time. Wait, about time to.
now muted.
Funny enough, Namboira na ikato, but I've to pay the because about
yangu yarana.
Yara and it. All right, get to Momira Bichana. Momira Bichana, I'm pizza. Sakana yako yarana, don't know, Pama presenter rights. Ndian, ani machine, ani iko IG machine yako shoma.
I3.
Iko I3. All right. Machine wangu na sondi ya this. All right, let me. Is there anyone else? Any Yarana foot? All right, Diani, Dr. Presenter rights. Who continue? Pema presenter rights. Let me use the other machine to grant you. Machine on what to freeze, but you don't go to pay. In the interest of time, okay, grant you presenter. Then you can proceed. No, not something else. Balloons. One, two.
You are now
So I machine, you know what to stick and then go restart. So in the interest and code execute. Another, what's your username?
Enoch.
All right, let me grant you presenter rights. You can proceed with the lecture. All right. Yari tena chi mavazi za tena yari tena.
Aina hapana mavali zambo sure.
Right, it's okay. okay, pane code yatinozorwa nayo. I want you to type or to paste code yandakanda papublic chat to see one output inobuda ivo.
Yeah.
Right. Alright, 44512. So remember, tapasa our cosine thing. Nonzi function iri pamusoro TDF yareceiver two parameters, two matrices, and it of the same name ari pamusoro, and so
Hello?
You are now.
Say what, Budan?
audible.
Yeah, we can hear you now.
So I want you to paste this code as an explanation for the code above the machine. Right? Just paste it. Do an anti-explanation. Right. So we want to access the cosine similarity for the element on index 1. To do that, just to call the cosine variable that I created. Then you with some square brackets to indicate the index. Just copy the cosine sim. Put it in the it's a row. It's a comment. Above shape is cosine then square brackets. Another what says element on index 0, the first element is a 0, minus a 0. It's a 1. Okay. So now we want to construct a reverse map of indices for the movie titles. Let me just paste the code in the public chat. Can you just copy and paste that code? But here we are saying, all right, let me just provide some notes that come with that code. Just paste them just on the screen, on the cell below, to say that code it constructs a reverse map of indices and movie titles using the pandas library Python. You just tora manota alongo by right. That is what we have accomplished there. And then we want now to build a function. Perhaps before we do that, we may want to slice the list indices of the 10 elements. All right. Let's just build the recommender function now. Because we're now good to go. So this is the function that I'm now pasting on your screen. Build recommender. You just copy it, then you paste it, you just run to see how it goes. So the code that I've just shared with you, it defines a function called get recommendations that takes in a movie title as input or as a parameter, and it will then output 10 most similar movies based on cosine similarity scores. Right. I want you to run that code that creates the function. Abo bana sim scores abo panoindendo unachicreate function tinoti def, then pana get all the other text unenge aligned, something like that. Try to run it and let's see how it goes. So we have just created our function that accepts input and recommends to us movies. And so we are now, what we want to do now is we want to call the function, and we want it to recommend. You can just copy and paste what's on the part chart. So here we have just provided alright. We provided input yavadoti recommended movie 1 up to 10. Looking at Apple pane the sim scores up. Look at one sort of pane comment around to get the scores of the 10 most similar movies. Not that 5. Pana sim scores up. It was a 1 and 6. But you can not recommend the 5. I not recommend the 5. Let's run the code. Okay. But we can no try runs once more. Just copy the movie runs once more from the output. Then put it as a parameter, as an argument. Then recommend 20 movies out of index 449. Chimbotamba neslice yako kana kuti chimbobvisa slice chikweza chifull column 10. You extract a portion it's again. Just run that. Run. Alright. Put together it undo, just undo. Museo rompetse. Control Z. Alright, run it. Let's see. Alright. So that is how you build a recommender system using the cosine similarity and the TIFD weight vectorizing matrix. And is there any question before we bring closer to this session for content-based recommender? So, banana Netflix, nana YouTube. Zvainoita manje inenge ichitoziva kuti uyu anonzi chikondwa panouya paYouTube vada kuona mari dzavo dzebhora saka inenge yakutomborekomenda kuti ana webhora ichindo zvinhu zvaari most likely to be interested saka inobva yakutokuisira parameter rataisa rakanzi The Dark Knight Rises by virtue of your test. So this is how websites build my recommender system. Is there anyone with the reaction? I've seen you have an error similar to my machine, hasn't it?
Yes, it's talking about memory.
Yeah, that's the same. That is the same memory. That is the same error that I've encountered. So what I'm going to do, I'm going to rerun from my machine and perhaps share it with you. The Jupyter Notebook. Also, who is sharing their screen? What's your name, Enoch?
Yes, sir.
Yes, you can also share with your colleagues your Jupyter Notebook. I'm going to share mine as well with additional comments to each cell that we executed. Then on with the reaction from what we've learned. Dr. Digito?
Thank you, Chikondo. I think we can end now. Then tomorrow we are not going to be serious as we were today. So we'll try to have less work in terms of assignments. I think I'm going to give you a test tomorrow, but you write it over some days. And so I think thanks so much for attending our lecture. When are we ending? So we have one more weekend, is it? All right. How many more weekends do we have? We are left with one.
Let me check the timetable. Maybe let me just check.
All right.